Let's talk about the division of polynomials. Before we get into it, let's start by defining some of the terms that we will be dealing with. The first thing is the dividend, and that is the thing that we are dividing. The divisor is the thing that we are dividing with. So if, for example, I have 3/2, 3 is the dividend and 2 is the divisor. The quotient is the result of what you get when you divide your dividend by the divisor. And then whatever you're left with at the end is your remainder, what is remaining. And for some cases, this can be equal to 0, but it's still there. It's just equal to 0. So using this information, you can come up with this following equation. And you could use this as a sanity check or to reverse engineer your division process. But essentially, if you understand what all of these components are, the only thing that you should be worried about now is the algebra. The first example we're going to look at is dividing a polynomial by a monomial, or dividing it by one term. And in this case, we don't really have to do a full long division because I'm dividing just by one term. You obviously could do long division, but it's just unnecessary in this case. So what I will do instead is just separate this fraction to give me 3 fractions because I have 3 terms in the numerator. So I get the first term is going to be 3x to the power of 4 divided by 3x cubed. The second term is negative 2x squared over 3x cubed. And then the final term is negative 1 over 3x cubed. And now you just simplify your terms. So the first one, we can see the 3's will cancel out and I'm left with just x. The second term, I have 2/3, so that stays. And then I have an extra copy of x in the denominator. So I have 2 over 3x. And then my final term, I can't really simplify it any further, so I just leave it as 1 over 3x cubed. And that's it. Now we're going to look at dividing a polynomial by another polynomial. So in this case, I want to do long division. To set this up, I will write out my dividend, which is 6x cubed plus 5x squared minus 8x plus 4. And I'm dividing this whole thing by 2x minus 1. To begin the long division process, I have to look at this term by term. And I focus on my first term, 6x cubed. And I ask myself, what can I do to my divisor to match that first term? So what can I multiply by 2x minus 1 to give me 6x cubed? And now the purpose of this is to get rid of the first term so I can divide everything else. So what do I multiply by 2x minus 1 to give me 6x cubed? It's just 3x squared. If I multiply 3x squared by 2x minus 1, I get 6x cubed minus 3x squared. And now, like I said earlier, the purpose is to get rid of it. And to get rid of that term, I subtract. So 6x cubed minus 6x cubed is 0. And then 5x squared minus 3x squared, minus 3x squared is 8x squared. And now all these terms on top, you can think of this like I'm subtracting them by 0, or you could just drop them down. And now the process begins again, where I'm looking at the first term and I'm asking myself, what can I do to my divisor, 2x minus 1, so that it matches, so that I can get rid of it? So what do I multiply by 2x minus 1 to give me 8x squared? It's just 4x. So if I multiply 2x minus 1 by 4x, I get 8x squared minus 4x. And then again, I subtract because I want to get rid of it. So 8x squared minus 8x squared is 0. And then minus 8x minus 4x is negative 4x. And then I drop down that last term. And again, I repeat the process, ask myself, what can I do to 2x minus 1 to match the first term, negative 4x, and here I just have to multiply by negative 2. So if I multiply by negative 2, I get minus 4x plus 2. And so I again subtract, so negative 4x minus minus 4x is 0, and then 4 minus 2 is 2. Now, you could just say, oh, this is my remainder, so I just divide it by 2x minus 1. Or you repeat the process all over again, and you ask yourself, what do I multiply by 2x minus 1 to give me 2? And that's just 2 over 2x minus 1. And so you're left with 2, and then you subtract, and your remainder is now 0, and you're happy. There's no more steps that you have to do, and your answer is all up here on top, and that's it. Let's look at one more example of dividing a polynomial by another polynomial. So let's set up the long division again. So I have 5x to the power 4 minus 2x squared plus 6, and I'm dividing this whole thing by x squared plus 2. So I do the same process. I look at the first term and I ask myself, what can I multiply by my divisor, x squared plus 2, to give me 5x to the power 4, which is just 5x squared. So if I multiply x squared plus 2 by 5x to the power of 2, I get 5x to the power of 4 plus 10x squared. And I subtract, and I get rid of the 5x to the power of 4 term, and then negative 2x squared minus 10x squared is negative 12x squared. And I can't forget about my lone term up there, and I have to drop it down. And so the process repeats. I ask myself, what can I multiply by x squared plus 2 to give me minus 12x squared? Pretty straightforward. I just multiply by negative 12. So that gives me negative 12x squared. 2 times negative 12 is negative 24. And I subtract everything once again, so the negative 12x squared term goes away. 6 plus 24 is 30. And so you could think of 30 as your remainder, or you could just keep going and ask yourself one more time, how do I manipulate x squared plus 2 to get 30, which is just 30 over x squared plus 2. And then you multiply and you subtract, and you're left with nothing, and you're happy, and your answer is up there, and that's it.